Did you see my message? In Google Classroom, I gave the message. Did you see?
Yes.
What you saw?
The topic.
The
The
topic I gave also, I commented on your test.
no, I didn't see it.
Here I gave. This one is going to you, right? This comment also is going to you.
Yes, yes,
So you got it in your email.
yes.
So
I
can
check
you
now.
read? Can you read it? What is written there?
In test.
Mhm. Read loudly.
1 minute, sir. Sir, that comment, right? The
Mhm.
about test 4.
Mhm.
Yeah, you told I got 38 out of 40.
Then continue.
Then all MCQs were correct in structured question 1C and 5A2. You got mistake. I did
Hmm.
mistake. We will discuss them in our upcoming class.
Okay, great. So we are doing that one now, huh? We are discussing the test paper first, huh?
Okay, sir.
Your all the MCQs are correct. There was uh, mistake here, huh? C, 1C. Uh, you wrote here 16. Acceleration is
Yes,
16.
yes,
And you wrote here time is 15.
yes.
And if you are calculating this, then the answer is coming 12. Is it coming really?
Let me check that.
Can you check that the answer
Yes,
is
yes, yes.
coming 12 or is coming different?
Sir, I got answer 220.
220 now you are getting. And
Yes,
another thing is the answer is fine. According to the question given, the answer should be 12. But the writing you wrote, those are wrong. According to the question, you see, the acceleration is given 1.6
yes, yes,
and the time is given 5.
yes,
So instead of 5, you wrote 15.
yes,
Instead of 1.6, you wrote 16.
yes, yes,
If we write 1.6 and 5, then the answer is coming 12.
yes.
So my question is how you got this 12? The answer
I
is
wrote
coming.
the I wrote the workings wrong, but I did the calculation correct in calculator.
Okay, okay. That one is
Yes,
one
I
thing.
was in a hurry. That's why.
Okay, okay. I understood now. So can you correct it here in your paper? This paper is with you, right? So
Yes, yes.
please do it correctly. Huh?
Okay, sir.
Here you can do correction here, right side with pencil. Huh?
Yes,
Here we can do with pencil. You write here 1.6 equals 20 minus u by 5. Then it will come
yes.
12. So you are losing here 1 mark. Eh? For the formula,
Okay, sir.
correct formula, I gave you 1 mark and other mark you lost. Here we have 2 marks for this question. See? 2 marks. Huh?
Yes.
Out of 2, you are losing 1. So did you correct it?
Yes.
And here you write -1. Yeah.
Okay, sir.
With your pencil, you write here -1. That it will be a record, huh? With you.
Okay, sir.
Then there is question 5A2. You wrote here 57,
Yes.
and here you wrote 75.
Yes.
Okay, so look at the question is given 55 and 70. Here,
Yes.
here you see from 70 to 80 seconds.
Yes.
So you wrote here 75. It should be 70, huh?
Oh,
And here it's written the constant speed is 55, but you wrote 57. So other things are okay. Other things are fine. What you have to do, you correct here 55, huh? 40, then 1, 2, 3, 4, 5. Here is 50, huh? Here is 50. And 1, 2.5. Here you will get 55, huh?
yes.
Here you will get 55. Okay.
Okay, sir.
Then we have here 70. 1, 2, 3, 4, 5. 70, huh?
Yes.
Correct it. Just correct it. That's it. So 70 is here. Then 71, 2, 3, 4, 5 here. So from here, we'll draw a line here.
Yes.
That's it. Constant speed. Huh?
Okay, sir.
So here you are losing 1 mark. This drawing, 2 marks. Huh?
Okay,
So
sir.
you got 38 out of 40. Now our plan is to continue with topic 4.
Yes.
We are going to discuss that one. Topic 4. Topic 4, the notes I gave you, that one, did you discuss? Did you go through that one?
No,
These
sir. I
notes?
didn't get time. I didn't get time.
Okay. We also did not discuss, right? This one?
Yes. Yes. We did not discuss.
Okay, so we will discuss it today, huh? The topic name is mass, weight, and density. So this topic is quite simpler, right? It is a simple topic. And can you please go through the learning outcomes? you have most of the ideas from before. Huh?
Yes.
From class 7, class 8, you have these ideas.
Yes.
So can you please go through the contents, the learning outcomes?
State what mass is a measure of amount of substance in a body. State that the mass of a body resists change from its states of rest or motion. State that a gravitational field is a region in which a mass experiences a force due to gravitational attraction. Recall and use equation weight equals to mass into gravitational field strength. Explain what weights and therefore masses may be compared using a balance. Describe how to measure mass and weight by using appropriate balances. Describe how to use a measuring cylinder to measure the volume of a liquid or solid. Describe how to determine the density of a liquid, of a regularly shaped solid, and of an irregularly shaped solid which sinks in water. Volume by displacement. Define density and recall and use the formula density equals to mass by volume.
So if you go through, you will see that this formula you know, right? Weight equals mass into gravitational field strength. Then you also know this formula. Density equals mass per volume, right?
Yes,
And you also know the water displacement method, how to find the irregular shaped objects volume, right?
yes,
And you know how to get the density of regularly shaped object. For
yes,
regular shaped object, we need formula to get the volume. Then after getting the volume, it's easy, right? Mass you can measure with the balance. Then measuring cylinder we can use to measure the volume of solid irregular shaped irregular shaped object. That one is solid. We can use measuring cylinder, and the liquid always we are using measuring cylinder to measure the volume, right?
yes,
And we have here mass, two definitions of mass. Mass is a measure of the amount of substance in a body. There is another one, mass of a body resists change from its state of rest or motion. Always we know if you are given one, for example, you are given one 20 kg stone. If you want to push it or pull it, uh, then the way you will get the resistance, if you are asked to push or pull a 5 kg object or 5 kg stone, then you will get less resistance, right, to push or pull.
yes, yes,
So this tendency of the object that if it is more with more mass, that is showing its condition. It's already it has, that is it is static. If it is in rest, it want to be in rest. Again, we can bring the idea like motion one. You think one of your friends is Tamjid, right?
yes,
And you had another friend, Zubair Mullah,
yes,
right? So if Zubair Mullah is coming to you with Zubair Mullah gone to Allah Subhanahu wa Taala, right? You know it. Hello.
no sir, no sir, I think.
He has got the food poisoning somehow and he died.
Oh,
Some days back I got the news in the messenger. Marwan Rafi told me.
oh,
So what we are saying that if a person with more mass, if he's coming to you with running, then you
yes,
cannot stop him, right?
yes,
But if your friend Tamrid is coming to you, he is not so heavy. You can stop him easily, right?
Yes.
So it's also inertia. Inertia can be in rest. Inertia can be in motion. Huh? Inertia means the position or the state one object has. Uh, the object wants to stay in that state. This is called inertia. You understand what is called inertia?
Yes. Yes.
Okay, so uh, we can define mass using the idea inertia. So here is the definition. You see, the mass of a body resists change from its state of rest or motion. That means if you have more mass, if the object has more mass, it will have more inertia. If it has less mass, it will have less inertia. Is it clear?
Yes, sir.
And the first one is very clear to us. The amount of substance uh, present in a body or available in a body is called the mass. Like if we have a smaller volume object, even very small, like iron, we are taking a
Yes.
small amount of iron volume, you will feel that it is very heavy, right? It has lots
Yes.
of
Yes.
mass. But if you are taking a bigger volume of cotton, even that one will be lighter than that iron, isn't
Yes.
it? So it's because of the amount of substance present in that iron or in the cotton. The one which is containing more amount of substance, that one is more heavier. That one has more mass.
Yes.
Is it clear?
Yes, sir.
Okay, so this one we got A and B. We had the idea, and mass remains same everywhere. Wherever you go, uh, your mass will be remaining same. Is because mass is coming from the first definition, that is mass is related to the amount of substance, right?
Yes.
Until and unless you are taking out some amount of substance from that object, the mass will remain same
Yes.
everywhere. So we got the idea of mass. Now we have C. uh, C, we are having gravitational field, right? Before going to gravitational field, we are discussing some more things about mass. Like here, E. In E, they are saying mass is measured using balance.
Yes.
We have different kinds of balances. There is beam balance. You know beam balance.
Yes. Yes.
Then
Yes.
we have top and balance. Uh, and we have now different kinds of balances, right?
Yes.
We have also spring balance. So here we have uh, this learning outcome, this term how to measure mass and weight using appropriate balance. So this one is also done, right? EF,
Yes.
both are done. This is very easy. Now we are going with this two, C and D. And the unit of mass, you know, right? SI unit of mass,
Yes. kg.
kg. Very good. And we have some other units like gram, pound, right? We are
Yes.
mostly using gram and kg, right?
Yes.
And for a smaller mass, we are using gram, and bigger mass, we are using kg. We have also tons, huh?
Yes.
1000 kg, 1 ton. And another unit is there, quintal. Hmm. Quintal, that is 100 kgs, 1 quintal. And there is another one that is mount. In our
Yes.
country, we have mount. This time you did the sacrifice. People are asking how many mounds of flesh you got in your animal, right?
Yes.
That is also used. 40 kg is 1 mount. So here we got the unit also, discuss the unit also. Now we are dealing with C and D. We have here gravitational field. Gravitational field means it's an area or it's an space or place uh, in that area or space. If you are bringing one object, any mass, then it experiences a force. Okay, due to gravitational attraction. You can consider or you can imagine that if you are going to space, you are crossing the atmosphere of the Earth, then you are going to the space, right? That
Yes,
time you will not feel any attraction towards the center of Earth. You will just float, right?
yes, there is no gravity.
Yeah. So that that place you don't have any gravitational field working on you. That's why. But whenever you are coming to the range of that gravitational attraction, that time you are feeling it, right?
Yes, yes,
You are experiencing that force. So that that range or that region where the force of attraction of any planet or satellite or any star is working, that region is called gravitational field. Okay, it's
yes,
a
sir.
region or it's a space where the gravitational attraction is working. Okay,
Yes,
gravitational attraction can work. That region is called gravitational field. If you go beyond that region, then no force of attraction will work on you. Is it clear? Gravitational field.
yes, sir. Yes.
Okay,
Sir,
then we have here. Yeah,
should we memorize these definitions?
you do not need to memorize. You just remember it. That's it.
Yes.
I think once you understand, you can make it.
Okay, sir.
Your own words, you can make it, right? You understood
Yes,
it.
yes,
So that's enough. If you can make it or you can make it understandable to anyone, you can explain it, that's enough. Now we have here weight, the formula of weight. Weight is the product of mass and gravitational field strength, right?
yes,
And here we have uh, this formula, gravitational field strength, how it comes. Weight equals m into g, right?
yes,
And you have before the formula F equals ma, right?
yes,
So this one, these two, we are getting acceleration, right? Acceleration, this one, this one is acceleration, and this one is acceleration due to gravity, right?
yes,
In kinematics, at last we got this
yes,
acceleration of free fall, and the unit was meter per second square.
yes,
So we are getting acceleration of free fall if the object is in motion, it's falling down.
yes,
That time we are getting the unit meter per second square. And now the object is static. That time the gravitational field strength we are getting its unit is Newton per kg. How Newton per kg? Because
sir.
weight is measured in newtons, right?
Yes,
So Newton is here. Then mass is measured in kg, right?
yes,
Mass is measured in kg. That's why G is coming Newton per kg, right?
Yes. Sir, what
And
is that unit? Uh,
what is the
which unit is Newton per kg is the unit for what?
this one? Gravitational field strength G.
Oh, the Newton per kg is the unit for gravitational field strength.
Yeah, when the object is Newton per kg and meter per second square is same thing.
Oh,
Hmm. I'm showing you that one. And when the object is static, it's not moving. That time
yes.
we are saying it gravitational field strength.
Oh,
And when the object is falling from up, like you are dropping one ball, right? That
yes.
time it's in motion, right?
Yes.
That time the same thing we are saying acceleration due to gravity or acceleration of free fall. Okay? Then we are using this unit meter per second square. Now I am showing you that how Newton per kg and meter per second square are equal. You see here we are getting Newton, right?
Yes.
So here we are getting Newton. And if you are thinking about this mass, then it's kg, right?
Yes.
Kg. And if you are taking mass here, then it's coming Newton per kg, right?
Yes. Yes.
And A, we know it meter per second square, right? Acceleration.
Yes.
So it's matching, right?
Yes, sir.
Is it clear?
Yes, sir. Clear.
So we are done till F, right?
Yes.
Now we are having this very simple thing. What I think you know all these things before. How to use measuring cylinder to measure the volume of a liquid. You know, right?
Yes.
You know, right?
Yes, sir.
And how to measure the volume of irregular shaped solid. You know that one also, right?
Yes. But
Can,
I slightly forgot.
yeah,
I don't
forgot.
remember
So
completely.
we can recall that one, no problem.
Yes.
What we can do, we are having one measuring cylinder first here with water. Huh?
Yes.
Here is water, okay?
Okay, sir.
And for example, the water volume is 30 centimeter cube, okay?
Okay.
30 centimeter cube. Now you are bringing one stone, right? One small irregular shaped object, the stone we are getting. Here we are getting the water. After the stone is given here inside, and this is your irregular shaped object. Yeah. So here the water volume is becoming 40 centimeter cube. So the first step, you are only measuring the water, okay?
Yes.
And second step, what you are doing, you are measuring the volume with the object. Same water we
Yes.
are keeping and same water we are just sinking the object or the
Yes.
stone. That is coming 40 centimeters. So what is the volume of the object? 10, right?
10, 10. Yes. 40 minus
So
10.
you are getting V2 minus V1, huh?
Yes.
That is giving you volume of the object V.
Yes.
That is 10, right?
Yes.
So you got the volume of irregular shaped object. Now you can find the density, right?
Yes.
How?
Density equals to
Before
mass by
before
volume.
before giving this stone in the water, you will measure the mass using the balance, right?
Yes.
Then your mass is there. For example, your mass is 30 gram. Mass is 30 gram, right?
Yes.
Then what is the density?
Density is 10. No, not 10.
3. Density is m
Yes.
by v, right?
Yes.
Here
30
we
by
got
10.
the formula, huh?
Yes.
30 by 10. So
10.
it will be 3. 3 gram per centimeter cube, right?
Yes.
Is it clear?
Yes, sir.
So we are done till I, right?
Yes.
And for regular shaped object, if you are given one regular shaped object like this, then you can measure the mass using the balance, right?
Yes.
For example, this block, we have a mass of 800 gram, okay?
Okay.
This one has a mass of 800 gram. Huh? Then we are measuring the volume. Its length is, for example, 10. Okay, then here we have
Yes.
4, here we have 5 centimeter, all are centimeter, huh? 10 centimeter, 4 centimeter, and 5 centimeter. So what is the volume of this block?
200.
Huh?
200.
200. Okay, so your volume is now 200, right? 200
Yes.
centimeter cube. So what is the density of this?
4.
4 gram per centimeter cube. Huh?
Yes.
So the density is 4 gram per centimeter cube. So all are done, right? Regular
Yes.
shape, irregular shape, all are done. Okay, all these things are written nicely in our notes. You can
Yeah.
go through, huh?
Okay, sir.
You can go through. All the things are written nicely here. You see, we have here inertia. Huh? More difficult to be pushed. The one with sand, right?
Yes.
This way. Look, inertia. Huh?
Yes.
We explained in the diagram. Then we have amount of substance. Huh?
Yes.
What is amount of substance? Then mass. Mass we are defining here with the amount of substance and also with the inertia. Huh?
Yes.
Here is the inertia definition. Hmm. And amount of substance definition. Huh? Then we have the examples of balances, right?
Yes.
And then gravitational force, gravitational field strength, weight. Huh? The instrument to measure weight, we are using Newton meter, right? Okay. And weight is a vector quantity, mass is a scalar quantity, huh?
Yes.
Because weight has a direction towards the center of Earth, right?
Yes.
And we have the differences of mass and weight. Huh? Look, we have here 5 differences.
Sir,
Then
should
we
we memorize it?
you go through, just go through. You it will come in your mind automatically. You know all this, right?
Yes.
You know all this. What is called mass? What is called weight? Then mass is scalar quantity, weight vector quantity. You can make it. Huh?
Hmm. Okay, sir.
And mass is same everywhere. Huh?
Okay, sir.
And weight changes place to place. And here we gave some examples, huh? How to measure the density of regular shaped object, huh? How to measure the density of irregular shaped object, huh?
Yes.
You understood them, right?
Yes, sir. Yes.
So, do you think it is difficult?
No.
You just go through, and it is a small note, only 6 pages, and you have to solve this, huh?
Okay, sir.
After after already you are done with the notes, right? So you can
Yes.
solve it now. Here we have. Can you read it? Read the MCQ, first one.
What happens to an object when it is moved to a location where the gravitational field strength is slightly greater?
Mhm. So what will happen? They are saying gravitational field strength is slightly greater, right?
Yes.
Then what will happen? Its mass will change,
No.
its density will change, its volume will
No.
change. Nothing
Weight
will
will
change,
weight.
right? Its weight
Yes.
will increases, right? Because
Yes.
weight is
Only weight.
related to gravitational field strength, right?
Yes.
So the answer is C. This
Yes.
way you have to solve, right?
Okay.
So can I give you this work now?
Yes.
And we have some time. You see, now it is 5:42. So
Yes.
we have more 40 minutes.
Okay.
This 40 minutes you try as much as possible the worksheet.
Okay.
Okay, and uh, tomorrow also you try. Today you
Okay.
try this 40 minutes, and if you have time you continue. If you don't have time you try also tomorrow.
Okay, sir.
Then you can send me.
Yes.
Is it okay?
Yes, sir. Fine.
You send me in my email.
Okay, sir.
Then we will discuss this one in next class.
Okay.
Okay.
Okay, sir.
Thank you so much for joining today's class. And this 40 minutes, please use. You consider
Okay,
this
sir.
40 minutes as your
Yes.
class.
Yes.
Okay. What we do in
Yes.
coaching center, that the students are coming and we give them some work. They are doing this work and they are showing us.
Yes.
The
Yes.
same way we will do now. Okay.
Okay, sir. Okay, sir.
Okay. Allah Hafiz.
Allah Hafiz.
Just send me.
Okay, sir.
Thank you.